Hi, Terry VanNoy. Welcome to Math Class with Terry V. Hope this video helps you out, and if you enjoy it, please share it, comment, or like it. And you can also go to my website, MathPowerLine.com. It's a math resource blog, lesson videos for students, and other resources for parents and teachers. Give me a call or go to my website or email. All right, let's go to today's lesson. Let's take a look at what I mean. This is the first video in the series about simplifying rational expressions. So we're going to start with some basic ideas here. What is a rational expression? Well, when you see the word rational in math class especially, put an F in front of the word and think of fraction. Okay, it does have to do with fractions that are from algebra. Okay, so think about it as an algebra fraction or an algebraic fraction. Okay, here's what I mean. A typical fraction may look like this, 2/3. Okay, but when we think of it as an algebraic fraction, we're going to add some variables and expressions, polynomials, monomials, and that type of thing to it. So it could be 2x over 3y squared. It's still a fraction, but now we have some algebra in there. And you know, you could even make some binomials and trinomials out of it. So for example, something like this. Now some of these can be simplified just as if it was a regular fraction. Alright? Now what I want to do is show you some problems here to work on. We're going to simplify these rational expressions, these algebra fractions, and there is a 4-step process. Alright, I got 4 examples for you to try. And number 1, 40x squared over 35x. We want to simplify that expression. Alright? The first step, as you can see over here to the right, is factor. Okay? And as you should know, that means to break apart everything that you see. Now, if I start factoring this, I'm going to come up with a list of factors, prime factors. Now, one way to do it is to do a factor tree. Now, I'm going to show that for this first number, but for the rest of these examples, I'm going to assume you know how to do a prime factor tree. So I'm going to go ahead and think of what makes 40. That's 4 times 10. I could have chose 2 times 20, of course. It doesn't matter as long as I keep breaking it apart to find its prime factors. So 4 is made up of 2 and 2. Those are both prime. And 10 is 2 and 5. Now I'm circling them because I know I'm done. Those are prime numbers when I'm all done. So 40 is actually made up of 2 times 2 times 2 times 5. I go ahead and make that list. And that's on the top. Now for 35, that's pretty easy. I could do that in my head. That would be 5 times 7. Both of those are prime factors. Alright, I'm going to use dots instead of parentheses for my multiplication. Now x squared, again, we want a factor, so I'm going to break that apart, and that's simply an x times an x. And on the bottom I have just a single x there being multiplied. Alright, so that's what it means by step 1, factor. Step 2 is to cancel out the common factors. Alright, so I notice a 5 factor is common in top and bottom there, and a single x factor is common there. Okay, you want to make sure they're exactly the same. Step 3 is to simplify, and that just means to put everything back together again. So once I've canceled out these common factors, I notice that I have 2 times 2 times 2 times x, and that would be 8x. That's my numerator. And then a 7 on the bottom. Now in this case, with rational expressions or algebra fractions, it's okay to have an improper fraction there. We usually just leave it the same. We don't make a mixed number out of it. Alright, now here's a shortcut. And maybe some of you have been kind of wondering, because you've seen people or maybe you've done it yourself, kind of the shortcut method. Let's talk about that. Alright, let me change to my canceling color here. So I compare my 40 and my 35, and in my head I know that 5 goes into both of those. That's the largest common factor, greatest common factor. So 5 into 40 leaves 8, and 5 into 35 leaves 7. Okay, and if that's all I can do with the number parts, the coefficient, now I move on to the variable parts. If this is x squared and this is x, I can cancel out an x there. Now what some students do is they cross out the x here and they just cross out the 2 because now it's x to the first. There's one x left over on the top. And that's fine, you can do it that way. Now it gets a little messy and you have to keep track of what you're doing, but it saves a lot of writing, as you can see. And now we can go to the next step and write our answer, 8x over 7. Let's look at number 2. 56k to the third over 42k to the fourth. Alright, let's go ahead and factor this out, step 1. And when I do a factor tree or I figure out the prime factorization in my head, I know that that's 8 times 7. So 2 times 2 times 2 times 7. And k to the third is 3k's multiplied together. And again, this is sort of the long way of doing it. You can also use the shortcut. Now on the bottom here, 42, that's 6 times 7, right? Well, 6 is 2 times 3. And then I have a 7. 2 times 3 times 7. K to the fourth would be 4k's multiplied together. Alright, the exponent just tells you how many k's are factors. Alright, let's do some canceling. Notice I have a pair of 2's I can cancel. I have a pair of 7's I can cancel. And I have 3 k's on the top to match the 3 k's on the bottom with a leftover k on the bottom. Alright. Obviously after a while you can find a lot of shortcuts here and kind of do it visually, but it's a really good idea to just check what you're doing. So step 3 is simplify. That means put it all back together again. It looks like 2 times 2 is 4 on the top, and I have a 3k on the bottom. Okay, a common mistake for students is to ignore the letters, maybe just look at it too quickly and leave those out. But here's my answer, 4 over 3k. Now again, I can do the shortcut method, 56 and 42. I know that a 7 goes into each, but if I really think about it, 14 goes into each. So 56 divided by 14 is 4, if you know your 14 multiples pretty well. And 42 divided by 14 is 3. Alright, if I have k to the third on the top, k to the fourth on the bottom, that means that there's going to be a single k left over. And although it's kind of messy looking, I do have 4 over 3k. Alright, I'm going to leave 3 and 4 up to you, and I'll show you the answer here in a few seconds. Alright, numbers 3 and 4, check your answer. And let me show you why those answers are correct. So the first step is to factor top and bottom of those expressions out, and that's what we have here. And then we want to cancel our common factors. So in the case of number 3, we got a pair of 2's that can go, a pair of 3's that can go, and 3 sets of p's on the top and the bottom. Alright, so we multiply back and simplify what's left. 7 on the top, 2 times 5 times p is 10p on the bottom. 7 over 10p. Hope you did okay on that. Number 4, I factored out. Notice how it's 9 times 7 will give me the 63, and it's 4 times 7 gives me the 28 on the bottom. Alright, let's cancel out our 7's and a pair of m's, and that leaves me with 9m and 4 on the bottom. 9m over 4. Alright, so this is the very first video in the series. Students, thanks for watching this. Look for the next video, which will be in the same title, how to simplify rational expressions, and it'll be problem set 2. Alright, there you have it. I invite you to go to my website now, MathPowerLine.com, or email me or give me a call. The way I work best with students is live online in my classroom. So if I can help you in any way, answer some specific questions, the first lesson with me is free as I show you how everything works. Alright, study hard and take care.